Hi everyone, a warm welcome to today's webinar. Obviously, we'd like to talk today about how we think we can help your injection molding design process with simulation. Runtime for today is about 45 to 50 minutes, so there will be time for some questions. So please type them in as we go through, and there will be some time for it towards the end. Just to let you know, the session is being recorded today, and I believe will be distributed to you post-event. So there'll be an opportunity to share that recording with colleagues as well. We do have a couple of quick questions that we wanted to ask you. One which we'll ask shortly, and then one just before we go into Q&A. So it just really helps us just to understand, I guess, what you're using and to learn a bit more about you. So, Hannah, if you'd like to put the poll on screen now, we'll just ask that. So hopefully that's open for you all, and you should now be able to answer that. Just like to know what you're using, really, if anything, which is always useful for us. So we'll just keep that poll for another 20 seconds or so. There's only this poll and then one more, so don't worry, we won't ask too many. But if you could answer those questions, that would be great. So I don't know if you want to close that, Hannah. I'm not sure how many people have answered just yet.
Yeah, we've got about 64%. We've got quite a few people using Moldflow Autodesk.
Okay.
Maybe we can leave it for just a couple more seconds.
Yeah.
A few more coming through.
Yeah, I'd be interested to know how many people don't use anything at all as well, if anyone's answered
yeah,
that.
That's the majority. 73%, nothing at all at the moment.
Okay, interesting. Yeah.
Okay, I'll close it now.
Okay. Yeah. So that's interesting. I mean, we know you know that still a lot of people aren't using it. I didn't expect it to be quite as high as that, to be honest. But obviously nice to see that some of you are using tools already. So what we'll do now, just give you a quick introduction in terms of who's speaking today and the agenda. So I'm Rob Shropshire. I lead the sales and marketing side of Origin Engineering. I'll tell you a little bit more about who Origin is shortly. But I won't be doing a lot of the talking, but I will be your point of contact moving forward if you do want to chat with us further post event. Really pleased to be joined by Simone, who works for Altair as their Vice President of Manufacturing Solutions. So Simone has about 30 years experience, give or take, in the PLM and manufacturing space. So a really great person to explain in a bit more detail what the Altair Inspire platform offers. And finally, we'll hear from Tim Dukes, who works for Origin Engineering alongside me, and has been supporting our customers and training them on the solutions that we offer for the last 10 years or so. So as we go into the agenda, as I said, 4 or 5 minutes from me, just in terms of explaining who Origin are and what our relationship is with Altair. I'll then pass on to Simone, who will take you through a little bit of an overview in terms of what the Altair Inspire Suite is, and share some customer stories as well, which I think will be useful. And then finally, we'll pass over to Tim, who will be the brave one, doing a live demonstration of the software and showing you how it all comes together. So if that goes wrong, we can all have a laugh at him. So just briefly, in terms of Origin, we're a UK based reseller of the Altair solution. So what we do really is support and train customers on how to use their manufacturing solutions, with a particular focus here in the UK and Ireland. So in terms of the solutions, we really focus on things that can help and really identify defects in the manufacturing process. So that would include things like mold flow, or injection molding simulation, but it also extends to other areas of manufacturing. So whether it's casting or forming or extrusion, we're interested really in providing technology that helps you to address some of those challenges or defects associated with those manufacturing methods. But as well as manufacturing simulation, we also focus on more, I guess, what I would say generic use cases for simulation, where we're looking at things like stress analysis or fluid flow or thermal analysis. So in terms of, I guess, origin engineering and how we view the marketplace and how we view our partner relationships and the products that we offer, they must meet certain requirements as far as we're concerned. One of them is a relatively low initial investment. So we work with a lot of SME, smaller businesses as well as larger businesses, but we want the technology to be applicable to everyone. So a low initial investment is important, but the other one is it being relatively easy to train customers on. So usually a day worth of training is what you'd need to get up to speed on something like the tool that you're going to see today. So we know that there are other mold flow simulation packages out there. We've heard from a few of you that you are using some already today, but I hope what you'll get from the session today is a product that has a fairly low entry point in terms of investment, but it's also easy to use and also gives users access to a full suite of tools. So I don't want to steal Simone's thunder, but actually doing more than just mold flow analysis, but branching out into other areas as well, which will hopefully be useful for your business. But Simone will talk a bit more about that, I'm sure. So I think in terms of our perspective, we definitely think that simulation use is probably a little bit sporadic. And what I mean by that really is that companies will only use simulation at certain points, typically at the end of the product development process, or they'll just simply be outsourcing simulation. So they might leave it to the tool maker as an example. That's not necessarily the wrong thing to do always, because we need those specialists to do certain types of simulation. But we do believe that by deploying simulation earlier, we can reduce product development costs and ultimately deliver better parts. So we think that even as we start to consider the design of a part, and we know that it's going to be injection molded, we should be designing that part with the manufacturing process in mind. And we should regularly use simulation throughout the entire process, so that we're quite confident really in terms of our method and approach before we even get to the stage of perhaps looking at what the tooling might cost. So we believe deploy it early, deploy it regularly, and we'll reduce some of those product development costs. Now, don't just take my word for it. One more slide from me before I pass over to Simone. So get ready, Simone. But it's always useful to look at some research that was recently done. I think we're probably looking at 2021 research, but really it was a research survey that was conducted by engineering.com, basically going out and asking manufacturing companies how simulation is being used. So the first question you see on the left is when do engineers use simulation? And what we'll see is that only 37% use it during the design stage. 59% use it just before manufacturing. A high portion actually wait until yields drop, or when something fails, or when a part breaks. So we think there's a fair amount of opportunity there in terms of adopting it earlier, and perhaps paints a picture that businesses' perception of simulation is usually to do it at the end or to fix a problem, rather than using it, I guess, as a proactive mechanism to improve the part in the first place, or to make sure that the manufacturing process is as optimized as possible before things even go wrong. If we look at the main risks that manufacturing companies face, or I guess the risks in terms of staying competitive in this market, the businesses were talking a lot about the cost of tooling in the first place. They were talking about delays in getting products out to market. And finally, we see on the right-hand side the advantages that businesses started to enjoy when they invested in simulation. So what's interesting here is that we see that the benefits that businesses enjoyed from simulation is in fact the solution to the risks that they are identified in the first place. So they were able to enjoy lower part costs, they were able to improve production, and they were able to reduce the amount of rework that was going on in terms of that method development. So I think the summary is plenty of benefits to doing more simulation, but perhaps many aren't doing it early enough, so there's still plenty of room for improvement there. So I said I wasn't going to talk much, so that's it from me. Hopefully that does set some context for you. But what I'll do now is pass over to Simone, who will talk a bit more about what the Altair Inspire platform is and how it's helped some customers. So Simone, over to you. Just tell me when you want your slides moved.
Perfect. Thank you so much, Rob. And yes, like you said, it's about the process, right? It's about establishing this simulation-driven design for manufacturing process. And let's start with an example. Here, what you are seeing on the screen right now is the initial idea for a self-injector, which is a smart device that you, for instance, used for insulin injections. And this is a project that we worked on with a customer of ours, Nolato, in the Nordic region. So everything starts with this idea, but then if we go to the next slide, there are several challenges that you need to address as early as possible when you start developing a product like this one. Of course, you need to look at the performance of the part, whether they are, the structural performance, impact, nonlinear simulation, the fluid flow performance, like in this case, of course, you have fluids inside, as well as the kinematic performance of the part. But it's not only about performance, it's also about cost and sustainability. So you need to make it both lightweight, maybe use some optimization techniques like that topology optimization that you see at the bottom of the screen, or consider different kind of materials like the fiber reinforced polymer that you see on the left hand side. Because again, you need to find the right balance between making it affordable, but also making it sustainable and most importantly, manufacturable. And that's where combining design with manufacturability since the very early stages of development is really key. So let's go to the next slide and take a look at how Inspire can really help achieving that goal. As Rob said before, Inspire is more than just a product. It's actually a suite of products. And here, what you are seeing are what we call the sort of the four pillars upon which Inspire is founded. The first pillar is really a very, very strong geometry engine. Inspire is not a CAD per se, but it has a lot of modeling capabilities, and you can really model your part and your mold using different techniques. You can use parametric surfaces, you can use solids, polyNURBS, you can even use lattice structures with implicit modeling and make it much more easier to manage. So that it is really enabling this quick iteration on the design since the very beginning, and that's very much combined with the computational physics. So the ability to integrate all these very advanced simulation, like I mentioned before, structural analysis, fluid flow, motion dynamics, in a very user-friendly manner, so that we are really democratizing this simulation technology that in the past was just for analysts and CAE experts, now it is available to all the designers, all the people that know the process but might not know all the theory that is behind this advanced computational physics. And the same can be said for design optimization, for generative design. In Inspire, it's all very well integrated. Of course, we offer topology optimization, and that's really an industry standard that we have been developing and improving for 3 decades now. But more recently, we added AI-powered design exploration capabilities. And not only that helps designing lightweight and more efficient products, but you can also analyze the manufacturability of the product and find the optimal solution for a specific manufacturing process, and try different processes, and the result might be different because, of course, the manufacturing constraints are different, whether you are 3D printing or for instance, using injection molding. And how can you do that? Well, Inspire includes all support for all the manufacturing processes, as we can see in the next slide. Today, we are focusing on injection molding, but really we support casting, metal forming, extrusion, additive manufacturing, 3D printing, and polyurethane forming. So since the very beginning, you are able to say, okay, let me see how I can make this product performing better, but also make sure that it is manufacturable, and I can actually play a little bit with the different processes and see which one is the best based on the performance that I want to reach, but also on the cost and the production numbers that I need to reach. And that's a very well integrated workflow. But so let's go to the next slide, because of course, you don't want just to trust what I am saying, right? And here is an example of some of the customers that are already using this process, and in particularly using Inspire Mold as part of their daily product development life cycle. And you see companies all over the world, some in Europe, some in Asia, some in the Americas, and across different industries. So you see automotive, you see electronics and consumer goods, but you see even plastic furnitures there. So it really spans across across multiple industries. And again, going to the next slide, to be even more specific, let's go back to our self-injector. And what's the key? What's the advantage? What's the pain that we are addressing with our simulation-driven design for manufacturing approach? We are really offering this very streamlined workflow, which includes, of course, not only the analysis of the manufacturability, but also the optimization of the performance of the part, all within a single integrated environment. And that's the experience of our customer Nolato. But then if we go to the next slide, we can look at another, actually even more advanced example. In this case, we are talking about material substitution. The part is a part for the rail industry. So, for instance, requirements very in terms of robustness and fatigue that are very stringent. And the part originally was a metal part, and thanks to this very complete workflow, the customer here was able to redesign the part using fiber reinforced polymers, generative design. You can see the sort of organic design, and again, not only the part was very well performing and very sustainable, but that it was 25% lighter than the original metal part that was replacing, with a 35% cost reduction. So again, you can see how this pattern is sort of repeating and really improving the process, the product development process. So with that, let's go to the next slide, which now you have seen pretty much what other customers are doing. Let's see how that can be achieved with injection molding simulation. And for that, I think Tim will show you a quick demo.
Thank you. Let me know when you got to pass it over to me, Rob, so I can share my screen.
I've stopped sharing my screen now, so hopefully you can.
Okay, so I should be hopefully sharing my screen now. Thanks for the introduction, Rob and Simone, and again thanks for everyone who has joined us. I will shortly be taking you through the Inspire Mold solution, hopefully giving you a fairly comprehensive overview. I won't go through what is injection mold and all that sort of stuff, as I'm sure most of you are all aware of that. But I'll be giving you a decent overview of the solution, which, as Rob and Simona have already introduced, is a tool that hopefully like any engineer can leverage and use and help you manufacture better parts through understanding the flow and the cooling/solidification of your material, which obviously should lead to less product defects and less costly tool reworks. So I'm just going to spend 1 minute just going over the user interface, as we'll want to jump straight into the demo and seeing how the actual software works in terms of injection molding. But just want to go over the user interface very quickly, because we do believe it's one of the cleanest, sort of easiest to navigate interfaces out there, which again lends itself to hopefully anyone being able to quickly pick up the software. I'm going to just bring in a part, and I'll explain all the formats you can open in a second. But when you import a part, this is your design window here. So anything you import into here will appear in your design window, assemblies as well. So you'll see everything there. It's pretty standard within design softwares and all that sort of stuff. In the bottom left, you've got your views tab. So here, all your views can be snapped to top views, snapped to different axes. You can store views. You can go from ISO to ortho. You can section views. You can do whatever you need to with views there. So everything that you'd expect to be able to do with views, you can do from this bottom left-hand corner. In the bottom right-hand corner, you've got your unit system. So here you can go from metric, imperial. You can also customize units. So if you like to see your temperature in a different to Celsius, or your pressure's different, and all that sort of stuff, you can customize it all in this box in the bottom right. Moving on to your tabs along the top. So first of all, you have your molding tab. I'm not going to go into this in too much detail now, but you've got your two modes, basic and advanced. In each of these modes, you've got a left to right workflow. So start on the left-hand side, work to the right-hand side, hopefully get some results. Next to that, we'll cover these in much more detail in a second, but next to that, you've got your geometry tab, allows you to create and make geometry modifications. And there's all these number of all these tools here. Also tools, in the drop down. So you can see here, there's some simplified tools. Let's just hide that section. If I wanted to remove holes in the model, easy to do so. Click your holes tool, remove them. That's your geometry modification tools. Sit inside next to that is your sketch tab. Again, create a sketch from scratch or use a sketch to modify existing geometry. So pretty straightforward. You've got your views tab or view tab. You can see I've got a model browser turned on. I also a lot of the time my property editor turned on. But what you can see here is it's just how you like to turn things on and view things. On the left-hand side, this is our model browser. Let's make this a bit bigger. but this is our model browser and property editor underneath. So obviously, as you import anything in, all your assembly structure will appear here. Anything you create in the software will appear here, and then underneath it is your property editor. You can see here, I can click on something, look at the properties of it, change the color, change the transparency in this instance, change the name. So pretty straightforward. Next to that, we have the edit button, window shortcuts, so everyone probably will be familiar with most of those. And then we have the file button, pretty standard throughout all softwares. So opening, saving, licensing, settings, that sort of stuff. Obviously, you can do screen captures as well if you want to screen capture and send someone a video. So that's about it for the introduction. One thing to note is we can import most CAD file types, so you shouldn't have any issue getting data into Inspire Mold. We can import Tier, SolidWorks, Pro E, Inventor, all your lot of your native CAD file types, but also all your CAD neutral file types like Parasolids, ACES, Steps, IGES. So you shouldn't have any issue getting data into the software. So I just thought I'd mention that as well. So that's about it for the introduction. In terms of the user interface, we'll just jump straight in and start using the software and hopefully show you sort of what it can do and the capabilities within Inspire Mold. So this is going to be the part that I'm going to focus my demo around today. But hopefully, again, you can just understand the principles and see the sort of results that we can get. So I'm going to start in the basic mode. This will basically allow us to get some quick results and an idea of part moldability earlier in our process. So as I mentioned earlier, there's always this left to right sort of workflow. So we're going to start in the basic mode. We're going to start with the first tool on the left-hand side, which is basically designate your part cavity or designate your part. If you do have a multi-cavity mold, you can designate multiple parts. So obviously, because I've only got one part, it knows which part to use. So here, this brings up our material sort of group, material grade, and then our sort of melt temperature. So we can click on here and we can look through all the different materials that we've got available. So I'm going to change that to 220. So you can modify all these. If I click on our materials library sort of database, it'll open up the materials database. Here we can start to look at all our sort of properties of those materials. And you can obviously create your own materials. You can edit the materials in here. It's worth noting as well that Altair do have further libraries of materials. Altair is the sort of global supplier to Campus, which you may have heard of, which is one of the leading sort of plastics databases in the world, and that was through their acquisition of Embase software a few years ago. So if for any instance your material isn't there, you may be able to get hold of it through one of their other libraries as well. So I'm just going to just leave these as the defaults for the time being. If your material does have fiber properties as well, just be noted you can simulate with fibers. But in this basic mode, I'm just going to accept that, and then we can move on to the next step. In a lot of these tools, there's a few different options, so just be aware that there's another option here, which is basically your mold opening direction. In Inspire Mold, the mold opening direction is always aligned with the y-axis. So if I look down here, it's always aligned with the y-axis, so you can sort of see which way it's going to open. You can obviously change the direction. You can choose another surface and have a different opening direction. I'm quite happy with this opening direction. I'm just going to move this out of the way. But you can see that blue is upper safe, obviously top mold, sort of bottom mold, and red is critical. So what red is basically, you can see this angle that we've got here. Anything under the 4 degrees is going to highlight red. Obviously, I can change the angle. I can change it to 1. I can still see all those faces are red. So, straight away, that's giving me an idea that maybe, depending on the material we're using, that part is going to struggle to come out of this mold. Before we actually create the mold, that's a cause for concern, and we want to probably go back and do a few design edits. But for the purpose of simulation, it's not going to cause me any issues. So I'm going to just accept that because I'm happy with my molding direction, and then we can move on to the next stage, which is gating. So here we've got sort of three tools to basically apply some gates. So this basic mode is great for investigating gate position, getting a quick idea of your flow. So there's 3 tools: gate optimization, which will basically look at the model and sort of recommend places to apply the gates. You've got gates, which allows you to obviously choose any location you want to apply them. If you've got geometry already that you've imported in that is a gate, you can just define it as a gate, and then we can specify an injection point if we need to. So I'll start with gate optimization, and here we can basically choose the amount of gates that we're looking to create. specify any ungateable locations or ungateable sides axes. And if you've got surfaces that you definitely can't add a gate to, you can also specify them. I'm just going to specify 2 gates and click the run tool. So within a few seconds, hopefully, we'll have some gates on the model, which we can see here. So you can see the software's applied these gates, as we can see. You can obviously go ahead and use those now and actually obviously run a simulation. You might not want to use them. You might just like think, okay, well, actually, kind of like the location, but I don't like where it's placed them. So I can obviously delete these gates. And then if you want to, you can say, okay, well, actually, I want to apply my gates there and there, you know. So it's totally up to you where you apply your gates. You can choose the size of your gates, choose the shape of them, obviously just reposition them using the move tool, and accept that. I don't need to define an injection point, because when you apply your own gates or let the software do it, you can see these green arrows, basically your injection points. Once you apply a gate, it's all good. Then we can move on to the next window, which you can see here says molding window. This is a tool that can be used to basically analyze the part and understand, get a best sort of optimal sort of fill time, melt temperature, and mold temperature. So in this mode, it won't sort of give you a definite answer, say, you know, fill it in 2 seconds, but it will give you sort of a guide, basically. So you can see here your molding window sort of opens, and you can see you get a fill time here, in this instance melt temperature. You've got obviously a grade, as you can see, as we start to maybe go above 4 seconds ish. You're starting to get into sort of the, you know, probably not recommended, not feasible, won't fill. You're going to end up with issues, short shots and other stuff, material freezing. So so you can get an idea. So you might already have an idea of, you know, what temperature you're going to, you know, the melt temperature, and, you know, based on potentially volume and stuff, how long the top part might fill. But you can also use this, so I know that I'm sort of going to fill around the 220 mark, around the 1 second. So I can sort of just click on these areas here. That gives me my melt temperature, mold temperature, and filling time. I can then say update initial values. If I close this now, what's quite nice here as well is obviously you can kind of get a little idea of how the part fills even at this stage. So you can see how the part might fill. But if we move on to a bit more of a comprehensive quick run, if I click on the final stage, and we've got our run options now, you can see here that these values that I've just taken from my molding window, fill time, melt temperature, and mold temperature, have all been updated. So they're the things that have come from that molding window. Obviously here we can specify clamping force, injection pressures. I can also simulate for sink marks, and then I can click the run tool. So just be aware this is a basic run. You're just understanding flow. We're not doing filling, packing, cooling, and warpage and all that sort of stuff. So I'm going to click the run tool now. And I like to do this live because we can, hopefully it shows the speed of the simulation. You know, generally within a minute or so, we'll get some results. So this is a great stage for just early in the design process, you know, early in, you know, your exploration stage, understanding how the part might fill, gate locations, you know, where potentially I might need to add vents. Because if you can understand that fill, you can understand where the sort of you know, where you might get air traps and stuff. But hopefully you can see the speed there. That's why I believe at this stage you can probably, you know, investigate 20 different gate locations within an hour. So so we've got some results, which is great. If I just modify, I like to modify my animation settings, and I'll make that a lot slower. So I've set it to tortoise speed, but these are your animation settings. Basically, you can do all sorts of stuff there. And if I hit the play button, we can see how the part sort of fills. Obviously, you can sort of manually control this. This is sort of your time, and you can manually sort of control this and pause it at any point and start to see areas where, you know, you might want to add ventings, and, you know, you can clearly see where we're getting flow fronts meeting, all that sort of stuff. But if we look to our analysis explorer on the right hand side, we can see that our results basically. So we can see we're just looking at fill time. So as we'd expect, sort of where we place these gates, where the sort of last areas to fill might be. We can see here, obviously, where we get these fronts of material meeting. But in here, we can also look at things like confidence of fill. So we can see straight away that this is all green, easy to fill, which is good. We've got no hard to fill areas, no unlikely to fill, and no short shots. So that's good. And we can look at other things, pressure drops. We can look at weld lines, obviously where we're getting these fronts meet, where you might see weld lines. We can look at gate contribution. Obviously, we've got 2 gates here. We can see actually how each gate is contributing to the fill. Look at other things. You can see different results. I won't be able to go through all the results in this stage and the advanced stage. So just hopefully you can see a few things there that will resonate with you. In this mode, we can also look for sink marks. So here, it's just basically giving us a quick idea of where you might see sink marks. You can see here, grey is no visible defects, green is barely visible. We can use this slider again and get an idea of, like, you know, are these barely visible? Or you can see as I move my slider bar from the no visible defects just above the barely visible, I'm getting nothing. So we're probably not going to see too many sink marks in this part. We've got quite a uniform thickness and that sort of thing, but you know, this will give you a good idea again if you potentially could see some sink marks in your part, and you can obviously allow for that. So that's the basic mode. We think it's a really good mode because it's really quick and it gives you a good idea of how your part might feel, and especially early on in that design stage where you think, oh, you've got quite a complex part and you're looking at gating positions. This is a great mode just to quickly get ideas of flows as well. So hopefully you can see the speed of that. That's the basic mode. So I'm going to move on to the advanced mode now. So I'm just going to just go into the advanced mode. What I'll do, I'm going to use this part again, just carry on sort of using this part and just show you what we can do with the advanced mode. So just to let you know again that there's no like different licensing modes for basic and advanced. You don't have to pay more for advanced. This is all just comes as the core software. So there's not, you don't just get the basic mode and you have to pay extra for the advanced mode. So we've imported our part again, and now we've gone into the advanced mode. Again, we start on the left hand side and work through to the right. You can see we've got a few more options in this advanced mode, and when we do come to actually run some simulation, we can do a multi-stage simulation where we are simulating the filling stage, we are simulating the packing stage, the cooling stage, and we can also simulate warpage. Again, it's worth noting in this, I'm not going to show you this, but we can simulate fiber orientation as well. So if your part has got fibers for added strength, you know, on all the benefits some fibers can give, we can simulate for them in Inspire Mold, and we can simulate fiber orientation. If you then want to know how that will affect your part in terms of strength and all that sort of stuff, you can do post-processing on it, and you can actually run then FEA on it with these fibers in your part, and you know, see how those affect your part in terms of structurally. So we're going to start on the left hand side again. Again, clicking on molding part. We've already gone through material, so I'm not going to cover that. I'm just going to literally leave it as the defaults, and I'm going to accept that. We know molding direction, we're happy with that. So again, it's exactly the same orientation as before, so something we've already looked at. In here, we do have another tool, auto configure components. So that is something that I will quickly show after at the end of this demo, and at the end of when I've shown you the results, I'll quickly show this auto configure components, and then because that's quite a good tool. You basically import a whole method. If you've got a whole method with all your runner system and stuff, and obviously all your multi-component system with your gates, your sprues, your runners, you can basically just specify an injection point in the software, like intelligently defines all the different components. But obviously we haven't got any method here, so I can't do that. But if I click on my runner system, move to the right hand side, I'm just going to have a quick sip of water. So we move to the right hand side. We've looked at gate optimization already, so I'm not going to look at that again, and I'm not going to define any gates. But what I'm going to do is click on straight to the runner tool, because here we've got another nice feature. If you are creating a multi-cavity mold, you can quickly set this up in the software, so you can specify the number of cavities, specify your gate shape, and then specify your injection point. So here, let's say, for example, I want to create a 4-cavity mold. This is going to be my injection point, and you can see it very quickly creates us a for cavity mold. These runners, gates, sprues are all parameterized. Sorry, all parameterized, and you can basically click on them, and you can see here that you can change the radius, change the height, change the radius. You can click on a gate. Oh, that's the part. But you've got part separation. You can obviously modify. You can modify the radius of the gate. So the layout of it is all sort of parameterized, and you can sort of just make changes however you see fit. Again, I'm just going to just accept that. So we don't need to do anything else now because we've got our injection point, which you can see here. We've got our sprue. We've got our runners. Another thing just to note is we can do hot runner systems. So you can generate hot runners, and this is great again if you have got things like valve gates. You have got material opening at different points in the filling cycle. I'll show you a quick demo of like one with a hot runner system set up with different valve gates and opening times. Just at the end of the demo, just so you get an idea of how that works. So we've got our runner system set up. Now we can move on to tooling. First thing to do is to define a mold. Here you can define the mold material, the mold temperature, and the mold dimensions. So that's all easily created. Again, I'm just going to right click and accept that. If you've got obviously mold inserts or part inserts, you can create or define them. So in each of these tools, just so you know, if you have got your own geometry and methods and stuff, there's generally like a designate. If you've got your own part, you basically just choose this option to designate it. You can click see in the runner system, if you've got your own gate imported in, you just say that's a gate using that tool. So we can define our inserts if we have any. In this instance, I don't. Call-in lines, obviously quite important. So we can create call-in lines or again, define them. So here, don't sort of judge my call-in lines, but I'm just going to just create some very quick call-in lines. At each stage, you can see you can parameterize them. So I can say the length. Every time I click, I can say the length. And you don't have to carry on. You can just have call-in lines straight through the part. But just to give you a quick idea, you can easily create call-in lines. And I'm going to accept that. And here again, you can specify your material, air, water, or any other material you're using, and then you can define a temperature and the radius of your cooling lines. So once you've done that, you can obviously potentially like look at them. You might want to move it into position, that sort of thing. So get it close to the part. I'm not going to go and create loads of cooling lines on this, but for example, if you wanted one on the other side, you could always potentially use your mirror tool, or you could just use your simple Windows copy and paste. So I copy, I paste, and then I could just move this one over to the right hand side. Obviously doing this very eyebally, but spin it around 180 degrees, and you've got another cooling line on the other side. So yeah, you can do all sorts of things like that. Added some cooling lines now. I'm not going to do any on the underside, but you'd have your cooling lines a lot better than I've just done them there. Moving on to tooling, the last thing in tooling is venting. So let me just hide my cooling lines. Every time you create something that's important, you can see that it appears here in the tree. So you can easily hide and isolate and turn things off. So I'm just turning off my cooling lines, and I'll just show you very quickly how you can add vents to the model. So easy to add vents. You basically just sort of on an edge, you can just sort of drag your mouse along it, and you can sort of create these vents. So you can see here, if you triple click on an edge, it'll just apply a vent the whole edge. If you double click on a face, it'll apply just the vents all around that edge as well. So obviously venting generally applied around the split lines, but you can apply venting however you want throughout the model, obviously to allow that air to escape. I'm again not going to apply venting all around the model, but hopefully you can see how it's applied and how easy it is. So moving on to the next stage, we've now got molding window. Obviously we're not going to go into that again because we looked at it in the previous window, but it's just exactly the same thing. Now we can look at process. So here we can specify fill time. So you might want to say I'm going to fill this part in 2 seconds, or if you know your flow rate or your inlet speed, you can specify those as well. And then you've got your settings for each stage, basically. So obviously my packing stage, my holding pressure, and all that sort of stuff. If I click advanced setup, you get you can see a few more things. So if you know that you do a simulation and your pressure's maybe not getting down to 0 or something in a certain stage, you might want to increase your packing time and that sort of thing. So you can change all these variables to suit. Again, hopefully these stand out and look familiar. Then you've got your machine settings. So again, these can be customized as well. So that's your process parameters. Obviously important to sort of get those right, but you can always play around with them. Obviously cooling, you can modify your temperatures, your end time and all that sort of stuff. I'm going to click OK there and then go straight onto the detailed analysis. So here, we're not going to do a quick run, obviously, because we've done that in the previous one, but you can, again, do a quick run in this sort of advanced stage with more detail. But here in this area, basically, we're choosing what sort of runs we're looking to do. So what sort of thing we're looking to do, filling, packing, cooling. I also want to do warpage because I want to see sort of that shrinkage. In order to do that, I need to take my slider bar to detailed and then click warpage. So now I can simulate for warpage as well. Here we've got our meshing options. Basically, this is another reason why we think this software is good, because it's sort of anyone who's used any sort of FEA, CFD or more advanced sort of simulation tools will know that pre-processing, the meshing stage, probably takes up sometimes a lot of time. It's sometimes can be quite a painful thing, but this software tries to democratize that. It tries to make it as simple as possible, as easy as possible, so anyone can sort of use it. So we've got auto mesh, which I tend to use quite a lot, but if you know, and you can see here number of layers, so in any given wall thickness it tries to put a number of layers, at least 5. But if you know your element size and you want a 3mm element size, you're welcome to type in your own element size and create that. So that's just something to note. As I mentioned earlier, you can simulate for fibers, so that's also good. And then once you're happy with it, you basically click the run tool. You've got some other options here in the thermal side for like heat transfer coefficients and all that sort of stuff. But once you're happy with it, you click the run tool and let the software sort of run and get you some results. So what this does, it basically goes into the meshing stage, meshes the part first, then it will go into the filling stage, then the packing, then the cooling, and then the warpage. So that's how it sort of works. I won't sort of let this sort of run on screen because it'll probably take about an hour and a half to 2 hours. So just to give you an idea of speed, again, how long would this simulation sort of take? Again, this will all vary depending on model and PC specs and stuff. But this model on my PC, using 16 cores, it took about an hour and a half. So that gives you a bit of an idea of sort of how long this sort of simulation would take. So obviously we're not going to sit here waiting for an hour and a half. So I'll sort of just open up one I did earlier, sort of Blue Peter style. So this is now my one and my run. What you can see here, if I open the results now and load the results, what you can see on this one is I've actually only put two cooling lines on the one side, just so you can sort of get an idea that you can see the temperature differentiation, hopefully in the cooling stage of each part. So just to show you what the effect of them. But we've got our results now. So straight away we can, again, let me just make sure this is on tortoise speed. And straight away we can see how this part fills. Get a good idea of how this part fills. So at the moment we're looking at velocities. Obviously it's all blue, so all the one velocity. If we section our model, if I put a section through the part, and as this part's filling, this grid's sort of dynamic, so you can sort of get an idea of how this area's sort of filling. And all your min and max values, they can be modified as well, so you can have different values as your lowest value, so you can highlight regions and stuff really easily. But you can see how the parts sort of fill in. So that's section mode. I'm just going to look at temperature. So here we can start to see our temperatures, and we can see how the part sort of, again, sort of fills, and our temperature evolution as it fills. So obviously here we can see as it's hitting these gates, obviously our temperature is increasing, as we sort of expect. One thing again you can do, as mentioned, is you can over exaggerate this area. So if you want to know, I know here I can see my max temperature in this thing is 340 degrees. but I know that my material temperature was about 240. So my melt temperature was about 240. So if I want to highlight all these areas and have the max temperature be 240, any area that now is red is above 240 or 240 or above. So we can start to see that. So really easy to modify your results here and how you wish to view things. In the filling stage, obviously, again, won't be able to go through all the results. We can look at pressures. Obviously, pressures are quite important, required pressures for filling. Obviously, filling time, we can see that here. And obviously, areas to fill last. We can look at frozen layers, so we can start to see these orange areas are not frozen, blue are frozen. Obviously, this will just probably be the very outer shell of the part. So if you do again put a section cut through your model, you can start to see that obviously these blue areas is just the very, very thin layer along the top. But you can start to see areas that are frozen. Obviously, if you are getting parts that aren't filling properly, maybe they're frozen somewhere that's not letting material through. You can start to look at air traps. So here we can see obviously air traps. Maybe I haven't vented this very well, but you can start to see here where we're getting quite a big air trap here. Obviously, so you can look at that and go, well, what's happening there? Let's just go back to look at how that material's flowing at that point. And obviously here we're getting this trapped air here where obviously no air can escape. Maybe I haven't had any venting. Maybe that's a venting location that's needed, and we can start to see that. So now we've looked at the obviously the filling stage. I'm just going to just quickly move on to the packing stage. I'm aware we haven't got too much time, so I'm going to look at the packing stage very quickly and look at the results that we can obviously get in here. In here we can obviously look at again velocities, temperatures, pressures, densities, sink marks. Obviously pressures might be important. You might want to be getting this pressure down to a certain level at this packing stage. If it doesn't hit that area, you might not see certain results. But so here we can start to look at sink marks. In this simulation, it's not actually predicting we're going to get too many sink marks. We did think that we weren't going to get too many based on the basic run, but that's been sort of confirmed. But here, as I say, you can look at other things like pressures, temperatures, mold temperatures at this stage, and other things. So I'll fly through the results, but cooling stage. And just obviously to note is you can obviously put call outs on anything here. So I haven't been putting any call outs. If I just show my call outs here, you can just delete them or hide them from here. I'll just create some new ones. If I want to know the temperature, sorry, put a call out there at this. I don't know why it's doing that. Click call out, put it on somewhere, and we can see. Obviously, at the end of the simulation, we can see the temperature difference because I've got a cooling line here and not one there. We can see a 77 degrees here, 49 degrees there. But as we're simulating, you can press that and you can see obviously that evolution as the part's cooling. We can see how the part cools down. Obviously, this one cools down much quicker than this one, which is obviously obvious because we have that cooling line. So obviously you've got your cooling line. Again, you can start to look at how the part is frozen at the end of the cooling stage. Again, you can take section cuts and start to look through the part and see where areas aren't frozen. So other things like that. That's the that cooling stage. Just to quickly, because I know I haven't got much time, I'll move on to warpage. Because I've got just I created a full cavity mold. It's only going to show the warpage results on sort of one of these, to be fair. But if you import your own mold, it'll show it on most of them. So here we can see how the part is basically shrinking. Again, you can put call outs. Let me just accept that, and I'll put a call out here, and I can see there that we're getting about a 0.9 millimeter shrinkage area in that area. Obviously, you can put call outs all throughout the model here, 0.7 millimeters. So you can start to look at the shrinkage rates of your parts as well, and obviously then you might either change your cooling methods, maybe it's cooling it, or you might allow for that in your design as well. So yeah, that's the software. I'm aware I need to sort of pack this up very quickly. As mentioned, I'll just quickly show you a one with valve gates. So I'm just going to just literally show you the filling of this. Here, if we click the play button, what we're going to see here is initially the valve in the center opens and lets material in. Then the next two open. I'll just sort of go through this a bit slower. and then these two open, and then finally when the flow gets to a certain point or a certain time, the other two can open. So so that's just with valve gates. We can do hot runner systems. The other thing that I did mention was I just wanted to quickly show you how the auto configure components. So if you import a part, obviously you can see here I've got a number of different pieces of in my tree, runner system, gates, sprues, all that sort of stuff. But with this auto configure tool, you can import it in, click on an injection point, and choose your material, and that just auto configures everything. So you can see everything's now configured: my part cavity, my gates, my runner system, and my sprue. So that's just another nice feature within the software. That's about it from me. I know I'm sort of running out of time, so I'm going to sort of finish it off there. Hopefully everyone's got a bit of an understanding of the software. We're going to pass it over to questions now. So if you do have any, we'll try to answer them at this point, and I'll pass back to Rob.